exponential function is just something of the form y equals a times b to the x. Okay. A and b are just representing numbers. X is your variable, so it might be like 2 times 3 to the x power, or 1/2 times 5 to the x. And you can have that number out in front, but the key is if it's exponential, the variable is in the exponent. If that base, the number being raised to a power, is bigger than 1, we call it exponential growth. Because the graph is going to be increasing. It just keeps getting higher. If your base is smaller than 1, so if it's like a 1/2, a 2/3, a 3/4, a number smaller than 1, that makes it exponential decay, because the graph is going to be decreasing. So the base is the number being raised to a power. And that's the one that will decide if it's going up or coming down. An asymptote, we'll start seeing those on our graphs today. An asymptote is a line which the graph gets close to but does not touch. So we'll see our graph getting closer and closer to this line, but it won't ever actually hit it. Today we're just going to graph them and then answer some questions from our graphs. Can you guys tell me, just by looking at this, will this be growth or decay? Growth. You're looking at this number, the base. If it's bigger than 1, it's growth. It's going to be growing. All right. To graph these, especially since we've never graphed one before, we're just going to make a T-chart. And we're going to plug in some values. So we'll just start, the first one, we'll just plug in some random things, see if we can kind of figure out what do we need to plug in as we move forward. So let's just start with 0. What is 2 to the 0 power? If you don't know, type it in your calculator. So it's just going in for the x. So 2 to the 0 is 1. So 0, 1 is a point on my graph. If I plug in a 1, what is 2 to the first?
2.
So 1, 2 is on my graph. If I put in a 2, what is 2 to the second? 4. If I put in a 3, what is 2 to the third?
8.
my points are off, aren't they? I just split all of them over. Let me fix that. 0, 1, 1, 2, 2, 4, 3, 8. Okay. So this is why it's growing. It's exponential growth. We can see this is just getting bigger, right? And it's going to continue to do so. Let's see what's happening the other direction. We can plug in things smaller than 0. So if I put in -1, -2, -3, let's see what we get. Use your calculator if you need to. What is 2 to the -1 power? ½ So -1, 1/2. What is 2 to the -2 power? 1/4. Okay, 2 to the -3. 1/8. Okay, these are just getting smaller and smaller. But we're never going to do 2 to a power and get a 0 out. All right, so this graph looks like this. It has an asymptote. It is getting closer to the x-axis, but it is not hitting that. A lot of times what we might do is draw a dashed line there to show that is a line we are getting close to, but not actually crossing. So when you look at your graphs, it needs to be extending both ways. So I need to see the arrow going both ways. I need to see that curve. And we need to make sure that we have those points from our table plotted on our graph. Now, we may not have to do this many points every time because we're going to see the graphs are all going to be very similar. Okay, they're all going to have this shape to them. It's either going to be going up or it's going to be coming down. The difference between growth and decay. But we need enough points to know for sure what our graph is going to look like. So we have to put in 0, positive and -1, probably positive and -2 for now. So we'll try those 5 points to get us started. Some questions. The domain. Domain is asking what possible values are there for x. If we look at our graph, that's like going from left to right. This goes forever to the left. That goes forever to the right. We can hit all x values, right? Is there anything you could not plug in for x? No. So if it can be anything, what do we write? Infinite solutions, we can say, usually we see all real numbers. That means you can plug in anything you want. And guess what? Every single exponential I give you, this will be true. So every one of these graphs, my domain is going to be all real numbers. When I look at my range here, it's all above that blue line. When I'm looking at my y values, what kind of numbers did I get out? Positives. My range is talking about the y, is greater than 0. We only have positive y values, so y is greater than 0 will be my range. Okay, my y-intercept. That's the point when we cross the y-axis, so that's right here. So that is the point 0, 1. When x is 0, what's your y value? And the asymptote. That's the line we're getting close to but not touching. So remember, way back when we talked about Hoy and Bucks. If it's horizontal, it's y equals, and that was at y equals 0. So my horizontal line, the equation of the line that we're not crossing is y equals 0. All right. Any questions so far? Let's practice some more. If I look at this one, can you tell me right now, is it going to be growth or decay? Decay, because it's between 0 and 1. That means our graph should be getting smaller. So if the number, your base, if it's bigger than 1, that's growth. If it's smaller than 1, it's decay. So it should be, I know right now, my graph should be falling. It's going to be getting smaller. We need some points. So I'm just going to do some positive, 0, and some negatives. So 2, 1, 0, negative 1, negative 2. That should give us enough points for our graph. So if I plug in 2, you can use your calculator. 1/4 squared, if you want, I don't care if you give me a fraction or a decimal, either one is fine. 1/16. So when x is 2, the y is 1/16. That is very small. When x is 1, 1/4 to the first is 1/4. Okay, you're welcome if you want decimals here, if that helps you with graphing. This is 0.25, 1/16, 0.0625, so you can use those if you prefer. If we put in 0, what is 1/4 to the 0 power? 1. Okay, negative 1. So put it 1/4 in parentheses and then negative 1 on the outside, and we get 4. 4. And if I put in negative 2, that's 16. That's already off my graph, isn't it? So my graph, I should be seeing a curve here as best we can. So we know we've got these. We are not hitting the x-axis. That's one big thing I want you to realize. We don't actually hit that x-axis. We are just getting close to it. On your graphs, I want to see at least 3 exact points. Sometimes, 16 is huge. 1/16 is really hard to graph. But at the very least, we can do the 1, 1/4, the 0, 1, and the negative 1/4. So I need to be able to see some exact points on your graph. Domain, that's talking about the x values. So you can think of it on the graph as you go from left to right. This one keeps going to the left, this then keeps going to the right. So what y values do we hit? Or sorry, what x values do we hit? And I already told you this would be the same on all of them. All real numbers. You can plug in any x value. Your range is talking about your y's. When I look at this one, I'm only hitting the y values above the x-axis, so that means y is greater than 0. Y-intercept is the point where we hit the y-axis, and that is 0, 1. An asymptote, the equation of this line, so horizontal is y equals, it's just at the x-axis, so that's y equals 0. So very similar to the last one. I'd like to do one more of these today. I'm going to call on people to help me because we have the the same people that are willing to answer questions, and the rest of you are just sitting there. So I'm going to call in some volunteers. So my table. Okay, we need to make sure we plug in zeros, some positives, some negatives, and see what we get. So I'm just going to do 2, 1, 0, -1, -2. You can put them in any order. We just need a few points. All right. Does anyone know, is this going to be growth or decay? Growth, because my base is bigger. Just as a side note, even if I have something multiplied with it, so everybody take a second, look up here, because first couple homework questions are going to be like this. You may have one like this. When I'm at deciding growth or decay, it's just the number in front of x. So I'm looking at this one, 5 is bigger than 1, so that would be growth. If I said 3 times 1/4 to the x, the number in front of x is 1/4, so that would be decay. Okay, so when you decide growth or decay, it's just the number in front of x. You can also use Desmos if you would like to get these graphs and check yourself. Also a good option if you're not sure if it's growth or decay, you could look at it. If it's rising, it's growth. If it's falling, it's decay. All right, so if I plug in a 2, Esther, what do we get if we put 2 into our equation? 9, and then there's a -1 on the end. So let's go ahead and do that. So 9 minus 1 will give me 8. So +2, +8. Jetta, if I plug in a 1, what do we get? 3, the first is 3, and then we -1 and we get 2. So 1, 2. Kale, if I plug in a 0, what do I get? Well, grab a calculator. Type it in. Here's your equation. And your x is 0, so type in 3 to the 0 power -1. So 3 to the 0 is 1. Anything to the 0 power is 1. And then we subtract 1 and we get 0. So 0, 0 is on here. All right, Julius, if I put in -1, what does it give me? You can give me fraction, you can give me decimal, I don't care on this. It's probably not a nice number. What'd you get? So -2/3. So -1, -2/3. All right, if I plug in -2, Riley, can you tell me what I get if you put in -2?
I don't know.
Yep. Should be in. Did you subtract your 1? Try that again. 3 to the -2, and then subtract 1 off the end. And that should give us,
That's what I got.
make sure. So that gives me -8/9. If you don't like that, you are welcome to do decimals. It's like -0.8 repeating. This one was -0.6 repeating. So we can see it's getting smaller. It's really hard to graph at that point. What number are we approaching here? Where's my asymptote going to be? It's not 0 this time. It's -0.6, -0.8. What are those getting close to? -1. And that's because there was a -1 on the end. That number on the end is going to be your asymptote. If you're not adding or subtracting anything, it's just 0. If I added 3, it's going to be a +3. If I subtract 3, it'll be a -3. So our graph looks like this. So just like we predicted, 3 is bigger than 1, so that is growth. It's getting bigger. Domain every time is all real numbers. My range, it is going up, so it's y is greater than, but the value this time it's not 0, it's -1. It's where your asymptote is. Y-intercept, the point where we hit the y-axis, is right here. It's 0, 0 this time. And our asymptote is y equals -1. You notice your range and your asymptote are very similar. My range is just greater than, my asymptote is x equals, but they're both the y and the number. Because your asymptote is where it doesn't hit, and then we hit everything above that. Okay, we're stopping here for today, and you guys are going to practice.